Hello and welcome to today's class. We're going to be continuing from where we stopped at the last class, formation of differential equations. So this is part 2. So let's take the following examples. Obtain the differential equation from the primitive y equal to a exponential x plus bx. So straight on with this one. How many arbitrary constants are we dealing with here? We're dealing with two arbitrary constants, which makes us to differentiate 2 times. So y is a exponential x plus bx. Now our y prime, which is the first derivative, is going to be a exponential x plus b. Is that okay? And our y prime is going to be just a exponential x. So this is equation 1, this is equation 2, and this is equation 3. Now let's reduce the equations. Let's solve the system of equations. So we cannot use the matrix method here, unfortunately, like we did in the last video. So we just have to solve this one simultaneously using the method of elimination and substitution respectively. Now assuming we say equation 3 minus equation 2, you're going to agree with me that we'll have y prime minus y prime is equal to, so ax minus ax is 0 and 0 minus b is minus b. Just assume that it's an invincible 0 here. Okay, it's not actually here before. So ax minus ax is 0 and 0 minus b is minus b. So this is equation 4. Then when I say equation 2 minus equation 1, for instance, then you are going to agree with me that we'll get y prime minus y is equal to a exponential x minus a exponential x is 0. Sorry if I said ax before, it's actually a exponential x. Then we have b minus bx is actually b minus bx. Okay, so you can actually leave it as b into 1 minus x. So this is our equation 5. Equation 5. Now you are going to agree with me that at this point we can now divide 5 by 4. So when we divide 5 by 4, for instance, we'll have y prime minus y over y prime minus y prime is equal to I will have b on 1 minus x divided by minus b. So b can cancel out b over here. Now I'm going to clear the board so that we'll have enough space to write what we want to write. Okay, from the previous part of the board we arrived at this point, so we are going to complete the solutions of our differential of this differential equation by cross multiplying. So when we cross multiply, we'll have y prime minus y prime multiplied by 1 minus x is equal to minus into y prime minus y. So we are going to get opening the bracket 1 minus x on y prime minus 1 minus x on y prime is equal to minus y prime plus y. So we are going to expand the brackets as follows. So you don't need to expand this first term, so you just leave it as a coefficient of y prime. So we can expand the second term because I can see a y prime on the right hand side. So if I do it this way, or I can even say minus, instead of expanding I can say minus into 1 minus x y prime, then plus y prime, and minus y equal to 0. Okay, so from this point, what are we going to do? We are going to leave this one the way it is. So assuming I factor out y prime, this is what we are going to be left with. We have 1 minus x, then minus 1 y prime minus y equal to 0. So we just factored out y prime. Is that okay? So 1 minus x y prime prime, and this is negative x, y prime minus y equal to 0. So you have 1 minus x, y prime prime, plus x, y prime, and minus y equal to 0. So this gives us the differential equation for this particular system. Now you're going to notice that for two arbitrary constants, the differential equation is going to be second order. In other words, it's a second order, meaning that the highest derivative is the second derivative term, d2y by dx squared, which in our case is y prime prime. So if there are three arbitrary constants, you're going to have third order differential equation. If there are four arbitrary constants, you have a fourth order, and so on and so forth. So let's look at another example, and we'll call it a day for part 2. Alright, in example 2, we are to obtain the differential equation associated with the primitive y is equal to cx squared plus c squared. Now this is really a very important point. I need to point something else to you. So this question was intentionally set, and you'll be like asking yourself, how many arbitrary constants am I dealing with in this case? But it's just one. It's still c, that's the arbitrary constant in question. So you're going to differentiate only once. Is that okay? So let's split the screen and begin. So differentiate once. So y is cx squared plus c squared. This is equation 1. Now y prime is given to us as what? 2cx, okay, plus 0. When you differentiate c squared, you still get 0 because it's still an arbitrary constant. So this is equation 2. Are we together? So how do you go about solving this one? Remember, in the final expression, in the final equation, you have to have eliminated all the arbitrary constants. So let me make c the surface of the formula from equation 2. So from equation 2, we have that c is equal to y prime over 2x. Okay, so we are going to put this in equation 1. So we get y is equal to y prime over 2x x squared plus y prime over 2x all squared, and we're going to get y is equal to y prime, right, x squared over 2x plus y prime all squared over 4x squared. Are we together? So assuming we multiply through by 4x squared, because the LCM in this particular case, it's looking like 4x squared. So I'm just going to multiply all terms through by 4x squared. So we are going to get 4x squared y is equal to, when you multiply this one by 4x squared, you're going to get 2x y prime x squared, then plus y prime all squared. So when you do the rearranging, you will get y prime all squared plus 2x cubed y prime minus 4x squared y is equal to 0. So this is the answer for this particular case. This is the differential equation that will be formed by this particular system, and you can see that this is going to be a non-linear differential equation because our derivative term has a power that is not 1. We have the square of our derivative term. So this is not a linear differential equation, it's actually non-linear. So thank you for watching this video. We are going to continue on 2 more examples on formation of differential equation. Don't forget to like and subscribe and share to your colleagues or anyone you feel that will need this particular video. So see you next video.